Okay, so imagine this. You build an AI agent. It's supposed to go read your support tickets, figure out what's broken, and fix small bugs on its own. Pretty cool, right? You go to sleep feeling like a genius, and you wake up and it's burned $4,000 in API calls. Not because it did anything smart, because it got stuck. It kept calling the same tool over and over forever, and nobody told it to stop. That's not a hypothetical, by the way. This happens to real teams shipping real agents right now. And today I want to break down exactly why agentic loops break, and more importantly, how you actually stop it before it happens to you. And look, I get why we love this pattern. The whole pitch of an agent is you give it a goal and it loops. Think, act, check the result, think again until the job's done. No babysitting. That loop is literally the entire value proposition. It's what makes an agent different from regular script. But here's the thing nobody puts in the demo video. That same loop, the thing that makes agents powerful, is also the exact thing that makes them dangerous. The loop doesn't know when to stop unless you teach it, and that's where things go sideways. So let's actually define it properly. An agentic loop is just this cycle. The model looks at the current state, decides on an action, calls a tool, gets a result back, and then decides again. Perceive, plan, act, observe, repeat. In theory, it stops when the goal is met. In practice, it stops when one of three things happen. It succeeds, it hits a limit you built, or it just doesn't stop. And if you didn't explicitly build that middle option, that limit, you only really have two outcomes, success or run away. There's no natural brake pedal built into the loop itself. Now here's my actual thesis for this video. Your agent doesn't break on happy path, it breaks at the edges. The weird tool response you didn't expect, the API that fails in a way you didn't handle, and when it hits that edge, one of four things usually goes wrong. It gets stuck retrying something that'll never work, it gets confused and starts making worse and worse decisions, it burns through cost way faster than you would guess, or it takes real actions in real world that are now hard to undo. Let's go through each one because once you name the failure, you can actually design around it. First one, the infinite retry trap. This is the most common one. Your agent calls a tool, the tool fails, maybe it's a bad API key, maybe the file doesn't exist, whatever. And the agent's reasoning is basically, okay, so this did not work. Let me try that exact same thing again, which doesn't work obviously. So it tries again and again. Nothing about the error message changed, nothing about the world changed. So the model just keeps making the same call in a loop, sometimes for hundreds of iterations because technically it hasn't hit its goal yet. So why would it stop? Second one is a little sneakier. It's called the context poisoning. Every step of the loop, the agent's previous action and its result get added back into the conversation, right? So that's how it remembers what it's done. But if one of those steps was wrong, let's say it misread a file or a tool returned garbage, that mistake is now sitting in the context as if it were true. And every decision after that point is built on top of that lie. The agent isn't malfunctioning, it's actually reasoning perfectly fine. It's just reasoning from bad information that it trusted a few steps back. And the loop just carries that error forward, compounding it. Third failure. And this one hits your wallet directly, cost explosion. Every single time the loop goes around, that's one full model call, sometimes with a huge chunk of accumulated context riding along with it, because remember, the whole history is getting passed back in each time. So a loop that should have taken 5 steps in 30 seconds can quietly turn into 300 steps over a couple of hours, and each one of those is built. You don't notice it happening in real time, you notice it when the bill shows up or when someone finally checks the dashboard. And the fourth one is the scariest, honestly, because it leaves the screen. If your agent can actually send emails, write to a database, or trigger a payment, a runaway loop doesn't just waste tokens, it does that thing repeatedly in the real world. It might send the same email 50 times, it might create the same database record over and over, it might refund the same order 5 times before anyone notices. A confused loop with real permissions is the difference between an annoying bug and an actual incident. So here's the mental shift that actually matters. None of these four failures get fixed by using a smarter model. GPT-5, Claude, Gemini, doesn't matter which one. A smarter brain inside the loop still won't naturally know when to pull the plug. This isn't an intelligence problem, it's an engineering problem. You have to build the guardrails around the loop, not hope the model figures it out on its own. So let's actually go through the four fixes, one for each failure we just covered. Fix number one, and honestly the easiest one to ship today, a hard iteration cap. Before your loop even starts, you decide the absolute maximum number of steps it's allowed to take, 10, 20, whatever makes sense for that task. Not a soft suggestion in the prompt, an actual counter in your code that force exits the loop when it hits that number. This alone kills the infinite retry trap completely. The agent might still fail at the task, but it fails loud, fast, and cheap instead of quietly forever. Fix 2 handles the cost explosion. Put an actual dollar ceiling on every run, tracked in real time, not just at the end of the month. Every tool call, every model call, add up the estimated cost as you go, and the second it crosses your threshold, the loop dies immediately, no matter what step it's on. Pair that with an alert, like a Slack ping, an email, whatever, the moment any single run crosses even half your normal budget. You want to know about the weird run while it's happening, not 3 weeks later on an invoice. Fix 3 is for the side effects problem. This is where you actually make real world actions safe to repeat or block it from repeating at all. Before your agent sends that email or writes that record, add a check. Has this exact action already happened for this exact request? If yes, skip it. This is called idempotency, and it's the single biggest difference between a scary agent and a safe one. Any action that touches money, messages, or user data should never be allowed to fire twice for the same reason. And the fix 4 fights the context poisoning problem. You need to actually be able to see what happened inside the loop, step by step, after the fact. Log every single action, every tool result, every decision the agent made and why. And for anything that's genuinely high stakes, deleting data, spending money, contacting a real customer, put a pause there. Require a human to approve that one specific step before it fires. You're not removing the autonomy, you're just putting a checkpoint exactly where the blast radius is biggest. So if you remember nothing else from this video, remember this pairing: infinite retries, fix it with a hard step cap; context poisoning, fix it with logging and a human checkpoint on the risky steps; cost explosion, fix it with a real-time budget ceiling; and bad side effects, fix it with idempotency, so nothing real world ever fires twice by accident. That's the whole production grade version of what looks like a simple tool in a tutorial. Agents are genuinely one of the most useful patterns in AI engineering right now, but useful and safe to run unsupervised are two different things until you build these four guardrails in. And if this helps, subscribe. Thank you.